We've already considered the ideas of cost, C of X, revenue, R of X, and also that of profit, P of X, where we calculate that by subtracting the cost from the revenue. And note that each of these depends on X, and as X changes, the cost is going to change, the revenue is going to change, and thus the profit's going to change. And in business, we refer to this rate of change specifically as the marginal analysis. Remember that that rate of change is nothing more than a first derivative. These ability to calculate these first derivatives that we learned in the last section, we're now going to apply specifically to be able to calculate marginal cost, marginal revenue, and marginal profit. As an example, let's consider where we looked at the cost of producing X items. If we imagine that we have a cost defined as 225 plus 2x squared, we can look at the cost of, say, producing 10 items and, say, producing 11 items. If I want to calculate the cost of producing 10 items, I'm going to plug 10 into the equation, and I get 225 plus 2 times 10 squared, which is going to result in $425 to produce 10 items. Likewise, if I plug in C of 11, I'm going to get the cost of producing 11 items will be $467. When I calculate the difference then in the cost of 11 items and the cost of 12 items, I have 467 minus 425, which results in a cost difference of $42. Notice that if we take the first derivative of that cost function, remember the cost function is 225 plus 2x squared. When we look back at our rules for calculating first derivative, that's C prime of X. This is going to be 0 since it's a constant. We'll bring the 2 out front and we get a value of 4x is our first derivative. And so that C prime, when we calculate it for 10, is going to be 4 times 10 or 40, which is very close to the approximation that we had when we calculated the change in cost over one item when we did it up here. This is what we define specifically as that marginal cost. It's the rate of change of total cost per unit in a quantity X. If we look at another example of marginal cost, we can calculate the change in cost from producing 101 items and 100 items. Again, if we calculate C of 101, we're going to plug 101 into our original equation. And we get a value there of 803. And then if we calculate C of 100 in this case, we'll do 500 plus 3 times 100. We're going to get 800. Therefore, our change in cost from 100 items to 101 is 803 minus 800. So when the production increases from 100 to 100 items, it's a change of $3. The cost of producing that 101st pin is therefore $3. Notice here that it's a linear cost, and so that marginal cost doesn't depend on X. It's the same no matter how many pins we produce, it's going to go up by the same amount. When we calculate C prime then of 100, notice that C prime of X is simply going to be 3. So no matter what X is, the change in cost is still going to be $3. Likewise, marginal revenue works similarly, except we're looking at revenue instead of cost. As an example here, if we have a manufacturer determining the price, remember that price is the demand function, where X is the number of tables produced and sold. We can find the revenue function. As a reminder, that revenue function is simply the number of items sold times the price. So in this case, it's going to be X times 117 minus x over 4, which leaves us with 117x minus x squared over 4. And then to determine the marginal revenue, we're going to need to take the first derivative of that revenue function, which leaves us with 117 minus 2x over 4. Or if we simplify that, 117 minus x over 2. And therefore, the marginal revenue when we're calculating it for 16 tables is going to be 117 minus 16 over 2, or $109. The revenue is increasing at a rate of $109 per table as that 16th table is sold. Marginal profit, again, works the same way. We are looking at the change of profit per unit in sales. And as long as that revenue is greater than cost, there's a profit. However, we can see that sometimes that profit rate, the change in the profit, is decreasing. For example, imagine we have a table manufacturer with this cost function and a revenue function. First of all, to find the break-even points, we want to set the two equal to each other. So we're going to have cost equal to revenue. We have 225 is equal to 2x squared. 225 plus 2x squared is then equal to 117x minus x squared over 4. When we simplify that and combine like terms, I'm going to get rid of the fraction, so I'm going to multiply everything through by 4. I end up with 900 plus 8x squared equals 468x minus x squared. And then combining like terms, I get 900x squared. Let's back up just a minute here. When we combine our like terms, we're going to end up with 9x squared in descending order minus 468x plus 900 equals 0. And then I can factor out a 9. I'm left with x squared minus 52x plus 100 equals 0. And when I factor, I get x minus 2, x minus 50. So my two break-even points are when I have 2 or 50 items of production. Now, if I wish to find the marginal profit, the first thing I have to do is find that first derivative of my profit function. So when I calculate my profit, I'm going to do revenue minus cost. And when you subtract those two, you're going to find your profit function ends up as negative 225 plus 117x minus 9/4 x squared. And again, that comes from revenue minus cost. So in order to figure out the marginal profit, I'm going to take the first derivative. This term goes to 0, and I'm left with 117x, excuse me, minus 9/2 x, and there should not be an x here, it's just 117 minus 9/2 x. And then if I wish to find the marginal profit at various points, I can calculate the marginal profit at 10 by plugging in 10 and getting a marginal profit of 72. I can calculate the marginal profit at 20, and I get a marginal profit of 27. And I can calculate it at 30, and I get a marginal profit of negative $18. Now, what that means, P prime is actually getting smaller as X gets larger. And that marginal analysis then tells us that the growth rate of the profit is actually decreasing here. And notice here, when it's 30, it's decreasing at a rate of $18 per table. Doesn't mean we're losing money, but rather it means that as production increases, the profit per table is less. And this is due to something where the costs are increasing faster than the revenue. The last thing we want to look at here is the marginal average cost. Average cost in general, if we have the cost and we want to calculate the average cost, the first thing that we have to do is calculate the average cost by taking the total cost and dividing it by the number of items. And then that marginal average cost is simply the rate of change of that average cost. So to look at an example, let's take the cost function that we have here. The first thing we have to do is find the average cost function. So to do that, we're going to take C of x over x. So we'll divide each term here by x. And notice in this case that average cost then becomes 0.02x. One of the x's cancels. Here, all of the x's cancel. And then I think it's helpful to go ahead and write this x to the -1, particularly if we're going to be finding that first derivative. Now, when we want to calculate here the average cost per lawnmower, notice that C of x, we're simply going to plug in whatever value they have for x. In this case, they asked us to find the average cost per lawnmower if 1,000 lawnmowers were produced. So I'm going to find C of the average cost for 1,000 lawnmowers. And when I do that, I get 0.02 times 1,000 plus 100 plus 2,000 divided by 1,000. And this gives us 20 plus 100 plus 2, or $122. And that is the average cost per lawnmower if 1,000 are produced. Likewise, we can calculate the marginal average cost if 1,000 lawnmowers are produced. And so to do that, we're going to take the average cost. And again, this is where writing it with the negative exponent is helpful. And then to find the marginal average cost, we're going to take the first derivative of this, which gives us 0.02. This term goes to 0, and then we get minus 2,000 over x squared. And now the marginal average cost when x is 1,000, if we substitute in 1,000 here, is 0.02 minus 2,000 over 1,000 squared, which gives us 0.02 minus 0.002, or 0.018. And this translates into the average cost per lawnmower is increasing at 1.8 cents per mower when 1,000 mowers are produced. And again, that is the average cost per lawnmower is increasing when 1,000 lawnmowers are produced. Average cost, but it's marginal, which tells us it's a rate of change.